Okay, so I think we can slowly start our today's webinar. Welcome all. I'm glad to have you here. I will start sharing my screen, and we will start with the slide, with the set of rules for today. So we have a very interesting topic: bridging electrical and mechanical design in 3D routing in SOLIDWORKS Electrical. And to complete the webinar in a proper way, I would like to ask you to turn off your cameras and turn off your sound. You can write your questions in the chat. We have a live chat, and those questions will be discussed at the end of the webinar. And we have also a survey, a poll in our live chat, so we can also provide some inputs regarding your background and regarding your previous experiences with the tool. So in that way we could better shape the webinar in one or another direction. I would like to start with a brief introduction of our platform, of our company, what we do and why we do it. Our company is called WiredWhite. Our platform is called WiredWhite.com. We envision ourselves as a network of engineers, as a platform for engineers that are supporting and guiding the entire process of becoming an engineer. And we see our role as enabler by bringing customers and partners together. Customers such as students or young engineers, less experienced engineers, and partners with engineers with a much more experience, industrial experience, project experience, and we provide our platform for them to collaborate, to cooperate. And we also give all the necessary tools which are integrated into our platform to make this cooperation smooth and enjoyable. And why we do it? Because we see our mission in acceleration and optimization of the diffusion of electrification worldwide. So we believe by building that platform, by providing that platform, we make it possible to enable the global cooperation, to enable the knowledge sharing, and to make, let's say, the electrification worldwide more accelerated. And we try to contribute to that. And today we have a speaker, Shehryar Khan. I would like to introduce him. He's an electromechanical installation design engineer with 5 years of experience in automotive systems. He is specializing in the design and integration of autonomous vehicle components, including compute boxes, ADAS, cameras, ECUs, and wiring harnesses. He has previously worked at Volkswagen Group. He gained hands-on experience in ADAS camera integration, and sensor design and vehicle packaging, and his experience spans 3D CAD design, SolidWorks, Altium, 3D printed enclosures, and wiring harness layout. And Shehryar holds a master's degree in mechanical engineering, and he has filed patents in mechanical design in China, reflecting his innovative approach to build and develop and design vehicle systems. He is also he's fluent in Chinese, and that makes it him possible to collaborate effectively with global suppliers and partners worldwide. And beyond engineering, obviously he is passionate about knowledge sharing, about teaching, and he has created multiple courses on wiring harnesses, on manufacturing and support for harness wiring harness manufacturing, and he helps learning and teaching best practices in electromechanical integration to his students. I'm glad to have you, Shreya. Welcome to our today's webinar, and I'm happy to have you as a speaker. And you can start with the introduction of the material.
Yeah. Thank you. Thanks, Dimitri, for a good introduction, and I welcome everyone who has joined this webinar. Definitely, it's going to be. So from here on, I will take you guys from what we can do in bridging the electrical and mechanical assemblies and components. This is what the main layout for today's webinar is. For the on the mechanical side, I have prepared a box which is being integrated with 3 different components. One is the network switch, and another 2 of them are 1 gig and 10 gig network switches. So what I'll do is put in the wire harness design and the wire harness components into this box. It means that I'll be provided, being a electromechanical engineer, I will definitely be telling my mechanical team that what positions are good for the components to be placed in. I'll be helping them as well. That's because the layout of the wire harness, it depends upon that, and it's very important to start collaboration with the mechanical team in the beginning. Once I get all my components inside a box or a main assembly, I will start creating my harness in the SOLIDWORKS Electrical. And for that, the first step would be to create a connector. So I'll show you along how we can create a connector, and how to bring it in SOLIDWORKS, and how to make its connection points, and what will be the connection point for the wires or cables as well. And we can assign as many connection points to a connector. And from here on, I will start demonstrating how we can do it. Because of the time, I think I'll be a bit quicker. So, yeah, can you see my screen now? Okay, and the voice is clear? Okay, good. I think everyone can hear. Anurag, can you hear me? Sorry.
Yes, loud and clear.
Okay, that's good. So I'll continue from here on. Sorry for the disruptions. So I was discussing about the connectors, connection point, and these cable entry points, how to create them. So we will go here and choose SOLIDWORKS Electrical, and then Electrical Component Wizard. And once it's opened, it will show us the routing path connection points, like how to create them and what are. Okay, it's already open here. Yeah, so here I can pick the CP point from manufacturer part. It will automatically capture the CP points from the manufacturer, which are being defined already. Dimitri, sorry, can you turn off your mic, please? Okay. Thank you. So from here on, we can add our CP points from the manufacturer part, and then if you start adding, it will start adding the CP points on the sketch which we have created on this plane. We can select the sketch. Once it will open, the window will pop up, something like this. here we can select all these, just a normal selection, press from top to bottom by using the shift, and also we can select the manufacturer part here, which is already being selected as RJ45 Ethernet, and the manufacturer's name as well. And then here the sketch which I have already created here, I will select that sketch. It will start populating all my connection points, which are in this case 8 wires coming out of the connector. So it will start automatically creating these connection points with its sketch, which is editable as well for each connection point, and the direction for each connection point will be outwards, coming out of the connector. So we can choose that, and then we can even take it to the reverse or frontal direction, whichever direction we want according to our plane settings. In this case, it will be in the rear direction. And from there on, we can also set up our EV cable connection point. It will also be from this routing path tab, which is here. And then we can here select the cable point now to create our cable entry for this plane and sketch. What it will do is create another cable point with its own EW cable connection point, which means that the connection point for the cables will be from this plane. And we can see it in the next slides, or what I will demonstrate here, that how SOLIDWORKS Electrical will automatically create these wires till the connection point of the cable, which means that I will now save this, whatever I have created, and also we have to create our EW path, which is going to be created by our 3D sketch in the direction of the cable connection point. The path, why we create the EW path, because we want to tell our route to be in this direction and from where it should start. So this is also important, because SOLIDWORKS automatically doesn't pick somehow doesn't pick the connection point by itself. So you have to at least tell him from where to start and how to do it. So these are the basics which we set up for our connector, which is the main part before starting anything. Then once this is done, I'll close this. And in the next slide, which we were talking about, once we are done with the CP points, we will open our SOLIDWORKS Electrical now, which I have already opened here. This window will pop up directly once you start your SOLIDWORKS Electrical, which means I have to create a new project. And in this new project, we will be creating our connector sketches and everything, and we can name it as well. So I'll do that. For instance, we select the standards and we select our language and stuff, and then we name our project as well. From like for instance, I'll give it as network switch assembly, right? And then here we can also give it its versions, editions, and all of these tabs can be filled in. And then we press OK. It will start creating the project files in its designated location, which is the location is automatically created in your SOLIDWORKS folders where your SOLIDWORKS Electrical is being downloaded. Now here, once this is opened, we will go to our document book. We will check our cover page, double click, and see that our name is appearing here for our assembly, and then the drawings list, This is the drawing list for each drawings which we are creating in SolidWorks Electrical: cover page, drawing list, line diagram, power and control. So we will choose here only our control or power for schematics drawing. It totally depends upon you, how many pages you want to create. We can create as many as we would like to. Here, this means the schematics we already have, and so I will put my schematics above the line diagram. Line diagram is also the layout diagram, which will later on be created for our harness. Here in this section, if we double click it, it will a page setup will appear, and we can then set up our page, our snap objects, snap fits, whatever spacing we want, how we want, how much it should be. For example, we can keep it as the value as small as possible, so that our lines then don't get any misalignment. That's what normally we do. You can keep it whatever you would like to do. Here would be again 1010, and then we can close it. So our snap objects and grid is selected, and it's been set it up. And now what we have to do here is, first of all, we go to our library here in this tab, and we would set up our manufacturer's parts manager. If we go in here, if I click here in the connectors section and go for search, because I have created my connector already by adding as a manufacturer part. I have created my symbol, and also the 3D body has been already imported in that. So from here on, I will search my connector, which I have named it already, and it's AM something. Let me search. Okay, yeah, it's RJ45 Ethernet. So here we can check its properties. So in the properties section, you can select your name, whatever name you want to give to your symbol and connector, and the manufacturer name as well, from where it's coming from. It's Asman WSW in this case, and then what class we can define it, the class of the connector, and then the user library, which is my own library which I have created for my connectors. And then whether it's a base part, connectors have different parts. Whether it's auxiliary, base, accessory, boot, sleeve, or whatever, you can just set it up here for your connector. And then the data sheet can also be uploaded once you download it from the manufacturer's website. And here down, we can import our 3D part from our folder directly in here, so that once we transfer our files to SolidWorks 3D, the connector will automatically be created. Now, from here on, once this is set up, I will go and create my circuit terminals. In this case, as I have already shown, that we have 8 connection points, so we will set up our terminal or the circuit terminals. For instance, we have 8 now. From the Add tab, I'll create my terminal and then select what type of terminal is it, whether it's a female or a pin. The crimp is female or male, and then if you just want to keep it something else, you can choose from here, but I normally choose terminals. And then in this section, once our circuit is defined in the terminals, we will change the properties of the terminals itself. Like, for instance, SolidWorks will start its terminals from 0, but I normally change them to 1, 2, 3, 4, 5, 6, 7, 8 from top to bottom. And also we can define our wire numbers in each terminal, and our wire gauge, wires, the diameter and the gauge of the wire as well here. So this is where we can set it up. And then further on, once this all is set up, we have cleared a big major step here, and I will add this connector. This is added up to my library here. So now from the schematics page, I'll insert my connector, which I have already set it up. I'll search for my connector from here, and we can look into different classes. These are the filters which we can use. And then definitely I'll select RJ45 and add it to my schematic with its terminals already being defined. And then once we select this, it will give me the option to create the reference name for it, like for our Ethernet switch. This can be port 1, this can be port 2, and we have to name these things beforehand. So I'll name this as RJ45 switch 1. And once this is done, we can also check other properties which we want and put some description here for the connector, whatever description you would like to, like it's 8 pins Ethernet, right? Ethernet connector. And then we click OK. And now here you can have a look at your tree and check whether everything is fine. We have 8 terminals and everything is in its place, and the orientation of the symbol. So for this case, I'll put it in the direction where my connection points will be. So I can press spacebar to change its orientation, or I can select from here as well. So I'll just press spacebar and then select wherever I want to put it. So here. So now we have a symbol and the connection points already set it up. Everything is here. So you can also insert your symbol, different kind of symbols. I have set it up for my connector in the properties already. If you right click here, you can see the symbol properties and also the component properties. So I did that in my, once I was setting up my connector. Here we can define its symbol from the library of the SolidWorks. Which side, whether it's left, and how many pins are there, we can just choose a symbol type from here and then just enter it and press OK. And from here on, we need another connector which is going into our this is from, and we can take it to another component. So what I'll do, I'll create another connector, create a new connector, and then search again. The same type of connector is here, so I'll just put that and define its properties. RJ45 ETH. Okay, this time it's 1 gig 1 gig switch. Right, and this is only because our component only has one port for Ethernet, so I'll just leave it as it is. I will not change its numbers. For example, 1, 2, 3, 4, 5, 6 ports, whatever. I'll just leave it as it is. And I have given the reference to it. So that's another thing, and it's 1 pin. It's again the same 8-pin Ethernet connector. And we press OK. Now this time I need to be a bit careful because I want to bring the face of the connections towards that. So for this one, I'll be just setting it up like that so that it can be aligned properly with our connection points, and then it will be easy to drag our wires into it. Okay, so it has created it the other way around. I'll just for this instance, I'll just delete I'll bring it again and rotate it. Let's see what it does. Yeah, this is how it should be. It's all about your spacebar, how you want to use it. Just rotate it and you'll see the face which should be facing your mating half connector. Right, so from here on I'll go to my wires, and then for the wires, the next slide we have chosen, we have created our connector, which is mentioned in that, like creating the symbols, component definitions and everything. And then here I'll be creating this kind of wiring schematic diagram. For this we need to go to our wiring library first. If we go to our library, I have already set it up, my wiring library, so I'll go to my schematics and then in fact project, and then from configuration I can choose it from wire style, and also we can add our wires in the wire style tab. I have already created a group for it, for my wire types, and from here we can choose it. Even if it's not there, you can create it. This was for our previous project which I was doing, showing me network switch assembly. Yeah. Okay, so let's create our wires. I think it's not in our project library, because from the configuration we can see that we have to define our wires for each project. In the library section, we would, in fact in the project section, we would go to our wire styles and then add a numbering group. In this case it can be anything. Let's take 3 as default, and then we would start creating our wires. And here, for example, I have the wire colors and the wire dimensions will be already defined. I'm not going to detail because it will take a lot of time. We can just create 8 wires here and then insert them into our connector. So each color can be chosen for our line, and then the wire standard, the wire gauge and everything can be chosen, and also the cable reference can also be done here. What type of cable we have for those 8, it's a Cat6. So I have created Cat6 already here, and we can choose from here. Once our wire style is defined, keep association, I'll come here and then take it to translatable data 1. Okay, description, I'll just put it in description as this. Yeah, so we can create 8 different wires, but I'll not go into detail again, and I'll just start creating as many as I can. So, and we can also define whether it's a phase or control wire. I'll keep them the same as control wires. Okay, it's already there. Since I have defined my cable core association to the wires, we can again select for each wire what cable core we want. I mean, it's still the same, sorry. It should be TE. We can come here and then choose from our user objects class. Let's keep it the same, any class. Yeah, the TE connector, the TE cable, sorry. And we use it as a connection and press OK. Here again, I'll change its properties. I'll make it phase. I'll make it control instead of phase. And then we keep doing this for like 8 wires. And from here on, what I can do is actually, I think I'm running out of time to create this connector here. I'll just load my previous project which has been done. I can come here. This was created before. Yeah, this one which I have created this schematic before, and the wires are being added to the connector. And how to add the wires, I can show you guys how to do that. Draw a single line, and then here I can select my group which I have already created. There are 8 different wires in it, right? I can select it, and then it automatically shows me the number of wires and everything in there. If I choose that, I'll not create them here. If I choose that, I'll just click, all the 8 wires are appearing, and I can just take it along and then terminate it into my connector. Right, so once this is done, I'll choose all these wires, right click, and then I'll associate it with the cable core, which I was mentioning earlier that it's Cat6T connectivity. That's how it's done. You have to click on the wire and it will start taking up automatically because you have already created your library for the wires. So the cable cores will be defined automatically. This is something very good by SolidWorks. And then again, similarly, I'll create another connector here, which means that it will be the same as that, but with the different properties, because it's going from RJ45 switch 2 to the 1 gig connector, and here it was, I think, 10 gig connector. Yeah. And once this is done, once everything is done here in the schematics, you can go to your project or also your process, and then you'll start populating your SolidWorks assembly, which you link with your template project. It will create assembly and link it to the template project. You press OK, it will bring you here, main electrical closet. Now here, what will happen is that once everything is done here, if I double click this, it will take me directly to my project which has been created. So I'll just close this, and once I double click it, it will take me to the project or the wire harness which has already been created. So how to do that, I'll show you in a bit. Yeah, directly my project will be synced to this section here, and this tab will appear in your SolidWorks 3D, and you can just right click here and then start searching for your project, and then once it's open, you just double click your main assembly, your electrical closet assembly, and then start populating your connectors to its respective position. So one thing I forgot to mention, that you can create your mate references for the connectors as well. But once you are defining your electrical component wizard here, it gives you the option to mate reference which plane or which side of the connector you want to be at the front or the rear. So this is another thing good from SolidWorks. Once this is done, so you will right click on these connectors, you can check its properties, and then here you have the solid body. Right click and then disassociate or associate it with the connector. So I have already created that, but for instance, if I want to create it from the beginning, I will, let's disassociate it for now, and then if I right click, it will start saying insert. If I press insert, it will the connector will appear, and I have to just attach it to this wall of the component, and then the mate reference will be created automatically. So I'm not doing that at the moment, but let's keep our association again. If I press this, it will associate it with the connector which is already being created. And we press OK. And then we will associate it with the 3D part or assembly. So yes, I'll keep it with the assembly. We have already, yes, right. It's done. And if we look here in our SolidWorks feature manager design tree, what SolidWorks do is, so this one is already created. And how to do that, how to create your harness. Let's suppose I don't have this assembly here. I'll go to my, once all my connectors are being populated, only the connectors, not the cables and wires, they will come in later. First of all, I have to create my path, which is here, by a 3D sketch directly into my assembly. And if we can have a look at it, this is a 3D sketch option. I had created 2 paths. You can create as many as you want. And then once this is created, this path will be used to create your harness automatically. And how to do that, if we can go to SolidWorks Electrical and then look here at this option, route harness, we select this. So the route harness option will take us to a new tab in SolidWorks. Yeah, here. So if I select my harness, which is already from electrical schematics, which has been added as a harness to my project, I will select my harness, for instance H1, and then I can select and press OK. From there, I'll just, next step will be just pressing this OK button. I'll use first access connection, which is coming out of my first connector, and that will be the access connection. You press that and then boom, your harness will be created according to the path you have already created, which was this one. Once this is done, you will hide that and your harness will be here created. This section will appear, everything will be created automatically, and then you can right click your route and then edit your route. Now this is interesting. I have already created my my route, but what it was before, like, it was something like this. Everything was going in and out at in different directions. Though I could have set it up straight and then brought it back via the splines, but I just left it to save time, and then I had to do it anyway to fix my route anyway, so I did that. Now here, what we can do is our clip will also be defined at its positions. They are already mated at its own positions. And then now I want to pass my route through these clips. How to do that? We'll simply go to SolidWorks Electrical, press route or edit through clip. What it will do, it will open its tab, and then I'll go to my current selections. Here I'll choose my clip axis. In this case, yeah, it's this clip which is highlighted, and then I'll choose its clip axis. Once I choose that, it's already showing me that I have lines being attached to this clip from its exit point. This is the main clip axis, which is the central point. And then if I press the line, it will show me which line it is. This blue line, which I have already created. From and to is already defined through our harness. And this is how it works. And we can even move it away from the center of the clip axis, and then we can create our route. And then these routes will be added into the clips. For instance, if I want to take both of these out, from the clip. I'll just unhook from clip, and let's unhook them. Yeah, this is already unhooked from the clip, and then what will happen if I press OK? It will create the path which was already defined. Now I'll go back here, select my clip, this time the other route, and unhook. I'm unhooking it so that I can pass it through the other side of the other tie clips. So for that we have to have our clips already mounted on our selected box or the assembly. Now what I will do is I'll choose another clip. For instance, which one should I choose? I want to choose this one for this wire and that one for this wire. For that cable, sorry, not wire. Yeah, this is the one which is being highlighted here, and then I'll click that and go to its clip axis, and I'll take it through that clip. Here we go. So our harness will follow the route by itself. Similarly, for the other one, if I go back to my, I'll close this one. I don't want to create two. I'll just clear this section. I don't want to put both cables through this route. I want the other one to be going through that route, through that clip. What I do, I'll quickly select that clip and then select its axis. This is my clip axis. And then if I press this wire or this cable, it's again taking the route through that clip. And I'll choose OK. Yeah, so now the color red and yellow, pink, purple, and yellow is appearing. This means that there is problem in this harness or the cable. It's because of the bend radius. So what we do, we just drag it all the way upwards until it corrects its direction. I'll click on the spline point and drag it. You just play around with it, drag it somewhere unless the gray cable appears, like this one. So this one is now fixed, and we can do similar for that one here. This one is also, this has came up with errors because of the color, I have noticed, but if you want to find out what those colors represent, you can go to edit wires. In the edit wires, you will see that these wires will have a warning sign on top of them. So which means that the cable bend radius is not correct. Right. So I'll close that tab and then see this one, whether that is corrected or not. Let's drag it a bit more. Yeah. And here in the edit wire section, I can just check it again whether my wires are correct. I think it's correct. There's no error on them. Yeah, there we go. And then we just press OK. All the wires are here. You can check its component references, pin references, everything from these tabs. Right, so let's close it. Yeah, so now our harness is already defined and it's already being passed through those clips. What I see is Okay, what has happened here? I think there is an error on this cable. I have to check it again. Let's do it quickly. Route, edit route. See what has happened. Okay, it's because of I'll check the electrical attributes of this cable. So there's no wires coming through it, which means there is an error in it. I'll close it and then check whether my bend radius is correct or any issues with that. I think this is too close. I'll just put a bit more bend to it. Yeah. Now what will happen? Still this is an issue. I'll go to my edit wires and check whether my wires are correct. Everything is passing through the cables W1, and so W1 was incorrect. There's no wires in it. Yeah, now I can see that it's highlighting in the wires. Again, 8 wires, which we chose. I'll just press OK and hope it works. No, I think there's still an error, but let's try it once more and then it will be fixed. Let's drag it a bit. No, drag it from here, from the a point must be here, or I can create a spline point as well, and move it somewhere else so that we don't get the error. Yeah, I can just create a point somewhere on this cable. So I'm taking a bit more time, just 5-10 minutes more, and then we'll be wrapping it up. There is my spline point. Now it gives me the spline axis, which I can use to move my cable in different directions. Yeah, now it's corrected. So the error is removed. So this is the correct bend radius, but again, we have to calculate our bend radiuses and choose our correct or exact bend radius which we have chosen. In this case, there is no error for the bend radius, which means that this cable can twist in these directions, and there is no error in it, and it's manufacturable, and it can definitely go through this route. Right, all our wires should be fine. Yeah, we have to check this again and again so that we can verify that there is no error here. Once this is done, we're good. Close our sketch tab and then our assembly tab. Okay. Now what the next step would be is to create our documentation, which is again a simple step to do. We can flatten our route, which I have already created for our previous flatten route. I'll open that. This is the option to flatten your route. If you click this, it will flatten my created or current route. So it's taking a bit of time to load. Right, so this is what it's showing me, and then I'll just flatten my route according to my requirements. I'll just choose my drawing options, and I'll show the length leaders, display the 3D connectors. What else? We want the connection tables, cut list, electrical bomb. I don't want auto balloons, wire display balloons, because then they will make my drawing a bit too much populated. Here I will just leave it as it is. It will create a straight flattened route for me, or if I want, I can choose any straight path or straight line, and then it can be its access point, and from there on it can create path for us. I just want to annotate it. I can choose the manufacturing as well, but for now we will just take the annotation, how it will look like in the drawing. Once you press this, it will take me, so it creates the flattened route automatically. I don't need to do anything for that. I'll definitely have to check whether it's correct or not, or the layout is fine or not. Yep, it seems that it has created it in the horizontal direction, and everything is here. It will automatically create my drawing as well, because I have already told SolidWorks to create the drawing for me with the electrical BOM, circuit, and connector tables. Let's check that quickly. And we can choose our page layout. We can just change it in the SolidWorks sheet tab here. So it has populated everything. Now we can see that the connection tables are there. Now we just have to move it around to have a clear view of everything. It'll be quick, but let's see how long it takes. Yeah. So these connection tables are used by manufacturers to define which wire is going from where to where while they are creating or manufacturing their harness. Yeah. Just trying to get a better view of this. Much better. So that we can see our length, how much length we need. That's another important thing, because we have defined our route paths. So once we will be assembling it in the vehicles or the prototypes, the length should be correct, and not short or not too long, because it will create issues for us. If the length is short, it's a problem. If the length is longer, we have to bend it and accommodate it in our box or our assembly somewhere, which is again a waste. So these are the techniques to avoid them, and then that's why we use SolidWorks Electrical and SolidWorks 3D to get in better concept ideas before manufacturing each and everything. Right. I'll just leave it here. This is our BOM. Oh, sorry, the circuit summary. What is going from where? I think my BOM is hidden somewhere here. No, this is a connector. Connection table. This is my BOM. I'll just show you guys. Sorry. Yeah, this is the BOM with the connectors in it and the cable, 4 cables, 2 connectors. This is the quantity and each and everything is defined. And then here we have the circuit summary, the length and from where and what is going into which component or which connector. Everything is defined in the circuit summary. That's all for now from my side. We can save this or whatever, we can play around with it and set it up and give it a better look. My lengths are here. This is from the cable starting point to the cable ending point, and these are the studs, or the stubs we call them in SolidWorks, and they are being terminated into their terminals. This is all from our webinar from my side. Definitely, if you have any questions, I'll hand over to Dimitri now, and we can discuss them.
Thanks a lot, Shreya.
You're welcome.
Colleagues, do you have any questions? You can raise them. You can try to switch on your mic and raise the question if you have one, or you can just try to post it in the chat. I think we have one question in the WiredWhite chat received just now, which is how can the 3D routing in SolidWorks Electrical be integrated into an existing mechanical design or CAD model?
Yeah. Okay, that's a good question. As I defined that in the beginning, that to integrate our harness or route into our mechanical assembly, the process is what I have shown you. It will definitely follow that. But again, you have to go through this process to integrate each and everything into your components. That's the short answer for it at the moment. Yeah. If you want to go into depth or detail, I can give you more details and we can discuss that. Thank you.
Okay. Thanks a lot, Shreya. Anyone else has a question that he wants to discuss, maybe regarding your particular application, what you guys working on currently, maybe from some daily tasks that you have on your desk that you would like to discuss regarding the SolidWorks Electrical. If not, I would. Yes, please.
Yeah, I have say a bit about it. Like even if you would like to discuss what I have shown you, or you understand how much you understood, if you have any question related to that, or anything which you don't understand, you can ask here and I can answer you. From the audience.
Maybe a question will arrive a bit later. I would just now continue with the slides. Let me know if you can see my screen.
Yeah, we can. I can see it.
Okay, perfect. So I just wanted to introduce to you also another multiple options how you can interact, let's say with Sharia directly, or maybe on some different tool or subject that you have a question with. So we have an area with our online courses. We have in particular on CAD and on the electrical engineering multiple online courses that you can have a look at, definitely. And also on the right hand side I have here a brief overview of our private consultancy or private tutoring option. Sharia is also a member of our platform, of one of our partners, and if you have any technical question, any let's say a daily task that you are struggling to solve, you can always have a consultation call with Sharia directly and work with him together on solving your technical issues in your model directly. And also we would like to give discount code to everyone, to every webinar attendee, which is here WiredWhite 10, and you will get a 10% discount on every purchase, be it online course or private tutoring. You will have a discount of 10% on every purchase. That would be it. Just last check if anyone else maybe have question now or would like to discuss anything regarding the topic of today's webinar, then it would be, let's see, for now the last call. But you can always, as Sharia mentioned, you can always get back to him with the question also after the webinar. I would like to thank you, Sharia, for giving the speech today. It was very interesting despite all the technical difficulties at the beginning. It was a very nice webinar. Thank you so much for giving us some insights into the SOLIDWORKS Electrical world, solving different issues. So yeah, any final words from your side, Sharia?
Yeah, sure. I think it's very interesting to see how the SolidWorks technology or the SolidWorks software is emerging and forward to integrate or bridge mechanical and electrical components together. It saves a lot of time for our manufacturers, for our prototype manufacturing and things in the vehicle industry and some robotics industries as well. So it's a very good tool to use before manufacturing your product, and it saves a lot of time, cost, and also lean manufacturing, and these things are very important to do before starting your project. And yeah, if you have any further questions, you can always come to me via WiredWhite or through my email. And I'm planning to do another WiredWhite webinar maybe with Dimitri in the next month about the Altium, which is another tool to create your schematics, harnesses, layouts, which can be bigger harnesses, bigger layouts, bigger schematics than what I have shown you, more complex. And I'll be sharing my idea and knowledge on that topic as well, as I have also good experience and how to integrate Altium into SolidWorks and create 3D routes. This is another thing. Altium and SolidWorks can also work together. They can also collaborate with each other. I'm using that platform as well, and then Altium is also a very good tool to use for creating your schematics, layouts, manufacturing drawings for your electrical harnesses. In the automotive, aerospace, and robotics industry, it's very helpful. Yeah. Thank you.
Awesome. Perfect. Yeah. So I'm looking forward to that next one, to the next webinar. And thank you so much, guys, ladies, gentlemen, for attending the webinar today. Sorry for the technical issues at the beginning, but I think it was very great today. And looking forward to the next one. Have a great evening. And you will have the access to the recording. You will have the offline version of the video and the slides after the webinar, and I will distribute them once the editing is finished by the team. All right, thanks a lot, and have a great evening. And see you in the next one. Thank you.
Yeah, bye.
Bye-bye.
Take care.